kids, my name is Ms. Lim and I'll be one of your teachers for Earth Science this semester. Our first lesson for today is rocks. Actually, it will be about rocks and minerals. Now, one example of a mineral I have right here is asin. Asin, that's your salt. And in any case, that's actually one of the most common minerals that we have on this earth. Aside from that, we'll be talking about rocks. Right here, I think this is my little diorite right here. And that, in the next couple of videos, we'll be talking about what they do, where we can find them, how do we classify them as well. So I'll see you in a little bit.
What's the difference between rocks and minerals? So based on this definition, we're going to go ahead with this one. So elements, they make up your minerals. Now, your minerals, on the other hand, combined together, like these three, they will form your rocks. So in a way, minerals make up your rocks. Now, minerals will have different properties associated with them. Luster, hardness, color, sweet density, and all these others. These ones are usually physical, while the others are usually chemical in nature. When we talk about luster, we oftentimes think about how sparkly a mineral is, because it talks about how light is reflected off of it. When we talk about hardness, we talk about the minerals with ability to resist being scratched. So this one we have quartz trying to scratch calcite. Among the two, calcite was the one that got scratched. This means that quartz is harder than calcite. There's actually a way to measure hardness that's called Mohs hardness scale. And here we use the number 10 being the hardest and 1 being the softest. So far, the hardest material that we have here in this scale is diamond, and the one being softest is talc. So another property that we have is color. When we speak about color, it's what color you can actually see the mineral to have. However, it's not always reliable because, as you can see, quartz here will have different colors associated with it. The more accurate property when it comes to color per se is streak. Streak is never changing. It's very consistent, as that is the color of the mineral when it's in powdered form. Hematite may look like it's grayish and black, but if you scratch it on a marble or any white surface, you will see that its streak is color red. So, oftentimes, a mineral streak will be consistent, unlike that of color, there's more variation. Now here we also talk about density as to how much matter is compacted inside the volume of the mineral, its relationship to mass to volume. Aside from that, we also have the crystal form, like how are the atoms actually arranged inside your minerals. Here we can see how sodium chloride is arranged. Sodium chloride is actually your halite. That is another mineral. We also have cleavage. So cleavage talks about the tendency of the mineral to break. Now different minerals will have different ways of breaking, such as expressed here. So there are many different shapes to it. Now, if cleavage is more angular, fracture shows how uneven the breaking of a mineral is. So a mineral could either have fracture or it could either have cleavage. Minerals can actually also be soluble in water. Some dissolve in water, some don't. For example, halite, your common salt, is actually composed of halite. Also, aside from that, we can actually use how it reacts to acids, such as hydrochloric acid. So some minerals react to hydrochloric acid. The reaction depends on the type of elements contained within the mineral itself.
And there you have it. Thank you for tuning in, and we will see you in the next couple of lectures. I do hope that you learned something, and don't forget that you have some little tiny activities that do come after this video. Bye!